मैं राकेश कुमार असवाल, सीनियर लेक्चरर, गवर्नमेंट आरसी खेतान पॉलिटेक्निक कॉलेज, सिविल डिपार्टमेंट। स्टूडेंट्स, आज मैं आपको शेयर फोर्स एंड बेंडिंग मोमेंट का चैप्टर बताऊंगा। ये सबसे इम्पॉर्टेंट चैप्टर है अपना स्ट्रेंथ ऑफ मटेरियल सब्जेक्ट का, और स्ट्रक्चरल पार्ट का मेन टॉपिक है। सिविल इंजीनियरिंग के स्ट्रक्चरल पार्ट का मेन टॉपिक है ये shear force and bending moment. See, there is a structural element. स्ट्रक्चर है, उसमें एक एलिमेंट होता है. There is a structural element which involves determination of shear force, bending moment and deflection is called beam. बीम बहुत इंपॉर्टेंट चीज होती है किसी भी स्ट्रक्चर में. That involves determination of shear force, bending moment, deflection. Deflection we will study later on, but in this chapter we will study bending moment and shear force and bending moment. So this beam is subjected to load transverse to its axis. So we will study about the beam first, because it is the important component or element of a structure, and this beam deals with this shear force and bending moments about which we are going to study today. Shear force and bending moment. So there is beam having following kind of support, or the characteristic and properties of beam depend upon the support. So first of all, we will study the types of support over which beam rests. First is roller support. What does it mean? When beam rests on a sliding surface, like a roller, or beam rests on a flat surface like a masonry wall. This is masonry wall. The H portion is shown in this figure. This is masonry wall. The beam is resting on this masonry wall. Flat surface, sliding surface. This is sliding surface. And as a roller, it rests on a sliding surface as a roller, or flat surface as a masonry wall. This support, try to understand, this support sustain only a force normal to this surface. This is R. This is R. This is R. Reaction. This sustain only this normal support, normal load. Only is force normal to this flat surface, we can see. This is roller support. Only one characteristic is there, that is normal support or normal load. Hinge support. Hinge support means no translational displacement is possible. And one more characteristic is there of this support. Translational displacement कभी भी नहीं होगा इसका, but here is possible. Here is not possible, but it is free to rotate. It will rotate freely like this, but translational displacement not possible. And we can say that this support sustain normal force as well as horizontal force. Normal force as well as horizontal force. Two types of forces. This support sustain. Third is fixed support. Fixed support means it sustain normal force, horizontal force and rotation also. All the three characteristics are there. It sustain all the two type of forces, and third type is of rotation. It sustain rotation also. That means moment is there. Rotation not possible. It is fixed. How can it make? It can be made by inserting the beam inside the wall. So that's why it sustains normal force, horizontal force and rotation. These three types of supports are there. We will study. We will calculate the shear force, bending moment, taking these three supports. The beam will rest on these three supports only. We will study. Now, these are the supports of the beam. Now, we will study the classification of the beam. When a beam is having both the supports roller, or one support is roller and other support is hinge, this beam is called simply supported beam. I hope you have got it. One support is roller, other support is hinge. It may be both the support roller. This is called simply supported beam. Supports characteristic we have studied already above. Now, the next is cantilever beam. When beam is having one support is fixed support, one support is fixed support and other end is free. No support is there, no any type of support is there. It is completely free. This type of beam is called cantilever beam. Third is fixed beam. When a beam is having both the support, fixed support, both the supports are fixed supports. This is fixed support, this is fixed support. Then this type of beam is called fixed beam. Third one is propped beam or propped cantilever. When a beam is, propped beam is also called it. When beam is having support, one support is fixed support and other is simply supported. Beam having one is fixed support and other is simply support, then this type of beam is called propped cantilever or propped beam. We can say propped beam also. Propped beam. Now, next is shear force. We will study the shear force. What is shear force? There is a beam, simply supported beam, and there are number of forces acting on this beam, W1, W2, W3 and W4. Fine. If we want to calculate the shear force at this section, CC. C, C. Then shear force at this section will be equal to algebraic sum of all the forces either left side of this section or right side of this section. Again, listen. Shear force at any section can be defined or is equal to the algebraic sum of all the forces. Here is W1, W2, W3 and R1. All the forces left side of this section or right side of this section, that is W4 and R2. And if we take the left side of algebraic sum of left side of forces and it comes upward, then left side of this is section CC. So left side of this section upward, then shear force will be taken as positive. This is sign convention, very important. Otherwise the question will be done wrong. If you don't take the sign convention properly or right, then answer will be wrong. The question will be the solution will be wrong. And if the algebraic sum of all the forces right side of this section is downward, then we will take it positive. Similarly, what is bending moment? Bending moment at any section, suppose here is a section where we want to calculate the bending moment. Then bending moment at this section will be equal to algebraic sum of all the moments due to these forces about this section is equal to the bending moment at this section. And if the bending moment comes clockwise of this section, left side of this section, then we will take this bending moment as a positive. Again, listen. When we want to calculate the bending moment at this section, then the algebraic sum of moment due to all these forces left side of this section will be equal to bending moment at this section. And if this bending moment having the sign clockwise and it is the left side of this section, so we will take it positive. And if it is right side of this section and the algebraic sum of moments comes to anti-clockwise, again we will take positive. If algebraic sum of all the moments left side of this section comes to anti-clockwise, then we will take this bending moment as a negative. So this is sign convention, that is more important. This is the most important. Students commit mistake to taking this sign convention. So please be careful when you take the sign of this shear force or bending moment. That's all. Thank you.